Okay, so guiding questions for our new unit. How do you know if something is in motion or not? What are some ways you can cause an object to be put into motion? And what factors affect an object's motion? So since we're learning physical science, we're really thinking about the physical world. So like, why do things move? Why don't we float when we walk? Why does it take more energy to go up the stairs than to walk on flat ground? So these are the questions we're going to be thinking about when we're thinking about motion and physical science. And in my little Bitmoji is telling you here not to worry if you don't know the answers to these questions. These are just questions to think about as we go through this unit. So let's talk about motion a little bit. So take a second and just look at these two pictures. You see a car, a street, some dude on a bicycle. There's a green bike lane. Just take a moment to observe it. So now that you've observed this picture, what is moving while these pictures were taken? What object is moving? You can put it in the chat or call out. Okay, so some people in the chat are saying the bike. So how do you know? How do you know that the bike's moving? Again, you can put it in the chat or you can call out if you feel confident. Okay, so Anthony says it moved from one position to another. How do you define its position? I know this is a hard question. I want you to think about it. How do you know if things are moving? Like, what a question. Okay, so the bike hasn't fallen over. So think about the background. The background of the first picture and the second picture, have they changed at all?
Yeah, the dude was in a different spot in the second picture.
Right, Sarah. So when you compare the background to the bicycle person, bicyclist, the only thing that's changed is where the man is, the man on the bicycle. Everything else has stayed the same. Right? So we can see motion as being relative. So to be relative means it depends on the situation, right? So by looking at this picture, the only thing that's changed is the man on the bicycle. So we can assume that the man on the bicycle is moving. Okay, so I know that's tough to think about. And physical science can be a little tough because it's stuff we already know, right? Like, you know, when something's moving, you can see it and be like, that thing's moving. But now we're going to be like scientists and really think about how does the world work in a scientific view. So what we're going to do for the next 8 minutes is I'm going to put you into some breakout rooms. And you are going to watch this video in your breakout room. And you're going to discuss these two questions in your breakout room. So I put the link in the chat. So let me know if you can see it okay. Breakout rooms. So I'm going to get you into your groups. I wish there was a way to like automatically set groups. But go ahead and open the slides. I'm going to let this load. Sarah. Sorry, I take forever to assign breakout rooms. I always do this. But if you're waiting for me, because I'm slow at this, you can watch the video, and then when you get into your breakout rooms, you're going to discuss. Okay, so you were able to see the video of the guy holding the water balloon in the car. So what was the perspective of our motion? How did the water balloon move based on the point of view of the person in the car? What did you guys discuss?
Right.
Yeah, it looked straight, right? He recorded holding the balloon while the car is moving, and it looked like it was moving straight. But then when you looked at the point of view of the person outside the car, how did the water balloon appear to move? Curved, right? So what was that like philosophical question they asked at the end, right? Like, does point of view, oh, go ahead.
It should, okay. I think it said, if facts are relative, is the truth also relative?
Right, I think that's a great question for us to ponder about life. But motion is relative, just like most things are relative. Oh, you know what? One of my favorite quotes is from Obi-Wan Kenobi. I know I'm a nerd, but it's okay. That he said, oh my goodness, like truth is based on your point of view. Someone knows it. Someone will Google that quote for me. But he has a quote that says truth is only based on our point of view. So that also is true in science, is that when we look at motion, so how things move within space, it depends on where we're looking from it, right? So it depends on our physical point of view, how motion occurs. So there's a couple ways we can describe motion. One of our descriptions of motion is how fast something moves. And you've probably heard this word before, but we define how fast something moves as speed. And speed is a scalar quantity, and it refers to how fast an object moves. And what the word scalar means is basically it does not have a direction. So the word scalar just means it does not have a direction. So when you think of Sonic, he goes fast. He just boom, 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 goes everywhere. And he's a really fast dude. So today we are going to practice calculating speed. And it's actually really simple math. And most of you guys are in algebra or 8th grade math, right? Okay, cool. So the math we're doing today is very simple. It's just sum division. And I'll show you a trick to make it even easier. And then to compare, great. So if you're in algebra, this will be like super easy. If you're in math 8, I'm pretty sure you've already done this, so it won't feel that crazy either. But like I said, all the math we do is like multiplying, dividing, adding, subtracting. All right, so I said speed is scalar, so it's just describing if something's going fast, that's just its speed, right? But the word velocity is a vector quantity. This is all just vocab. Velocity is vector, and that means how fast something is with a direction. So I could say that car was driving 3 miles per hour north, right? That's literally the only difference. Okay, and remember, we're in science, so we're going to use our science vocab. When you're in real life, you use those words differently, but we're talking about science class words. Science class, speed, how fast you're going. Velocity is how fast you're going with a direction. Literally the only difference. So this video here is going to walk you through how to calculate speed, distance, and time. But instead of showing you that video, I'm actually going to just show you on paper. Your book, or not your book, what am I saying? Your packet. We're actually going to turn to page 26, and I'm going to show you how to calculate for speed. So give me 1 second. I'm going to stop sharing my screen. And you should be able to put Zoom into speaker mode so you can see my writing. And I'm going to show you how to calculate speed. Okay. So one thing to note is that in your packet, at the very front on page 4, you have what's called a reference sheet. Your reference sheet has all of the formulas that you will need for this unit. That means you do not have to memorize any formulas. They are all here. On the SOL, you get all of your formulas. So don't feel like you have to memorize these. You might accidentally memorize them because you use them a lot, but I do not expect you to memorize them. So today we are going to be looking at this first formula, which is the velocity formula, which also is the same as the speed formula. Okay, that's because the only difference between velocity and speed is that velocity has a direction. Everything else is the same. So we're going to be working through these different formulas this unit, but we're starting at the very top here with velocity. Okay, so if you're ever like, what's the formula again? Page 4 in the front of your packet. But today we are going to page 26. All right, so page 26 at the top says distance, time, speed, practice problems. So you can use your calculator, but you must show all of your work. And I only say that because I do believe showing your work helps you be better at math. Our formula for speed is that speed is equal to distance over time. That's the same thing as velocity. Velocity is equal to distance over time. It's the same formula. So you can use those interchangeably. The only difference is that one has a direction, the other one doesn't. Right here in this corner, you have a little memory device to remind you how to do this math. So if you're given different variables, you can use this triangle to help you remember what to do. If this is confusing for you, don't worry about it. You can also just solve for your missing variable, like if you were solving for X. Okay, if you're really good at that in algebra and you're like, I know how to solve for X, I know how to isolate a variable, good. If you don't feel comfortable with that yet, you can use this little device. So this device reminds us how the formula is set up. So if I am trying to solve for distance, I multiply speed times time. If I'm trying to solve for time, I do distance divided by time. If I'm solving for speed, I do speeds equal to distance divided by time. Okay, the video that's in the slides also helps you understand this little trick. And if you want me to go over more problems like this, I'm more than happy to, but this is just an optional tool for you. All right, so let's do a practice problem on speed. And you guys can see this okay? It's not blurry or anything? It's good? Okay, so I'm going to show you how I set up problems. Different people use different ways, and you just do whatever works for you. The way I solve physical science problems like this is I write all of my variables on one side. So I know that speed is equal to distance divided by time. So I'm going to write my 3 variables like that. Close in a little bit. Speed equals distance equals time equals. That's going to be my first step. Now I'm going to actually read the problem. It says, if a car travels 400 meters in 20 seconds, how fast is it going? So now I'm going to underline where I can identify my speed, distance, and time. So do I know my speed from reading this problem? No. So I'm just gonna put a question mark, or you could put an X if you want for your missing variable. Do I know my distance? Yep, 400. Someone said in the chat. 400 meters. And then my time is 20 seconds. So now I've identified my variables. So I need to find my missing variable, which in this case is speed. So I can write out my formula like normal. Speed is equal to distance, which is 400 meters, over 20 seconds. What is 400 divided by 20? 20. So I get 20, and this is the important part, meters per second. I got that unit, meters per second, because I did m divided by s. So you have to treat your letters just like you would treat them as a variable. Like if it was an x and a y. X divided by y is still x over y. So same deal here. You treat them like variables, but they're units of measurement. Okay, so there's an example for calculating speed. I want to know what my speed is. I can use my formula like that. I'll let you do the other two during asynchronous time. But let's look at some other types of problems you would get on this. If you had to solve for time, you could flip around the formula like this. So the way they got this is they drew their little pyramid. Like I said, you don't have to do this if you don't like it, but it is helpful for some people. So I'll show them. So here's my little triangle. Distance or speed is equal to distance over time. Right, speed equals to distance divided by time. That's what that triangle tells me. And this time, I want to know time. So this literally looks like this. If this makes sense. You see how that makes, how I got that? It's like a really visual way. You might not like it. I'm not going to force you to use it at all. But that's what the triangle is for some people who are a little bit more visual. Yeah, okay, cool. And then you can rewrite it like this. You know, algebra, you rewrite things all the time. Okay, so now that I've got that down, I'm gonna look at this problem. So I'm gonna do my same deal over here. Speed equals, distance equals, and time equals. So I'm gonna read the problem. How much time will it take for a bug to travel 5 meters across the floor if it is traveling at 1 meter per second? So I'm going to underline any numbers. That's always important. Do I know a speed from this problem? Yes, what's our speed here?
It's 1.
1, right? 1 meter per second. What's my distance?
5 meters.
5 meters. And do I know the time?
No.
No. So I can put a question mark, or you can put an X for your variable if that's what you prefer. So now I'm going to set up my formula. So I said up here that I could rearrange my formula to solve for time, because that's what I'm missing. So I could say time is equal to distance, which is 5 meters, over speed, which is 1 meter per second. And what's 5 divided by 1? 5. And my units need to be in time because that's what I'm solving for. You could also look at your units and see how they cancel out. So m divided by m, those two m's cancel out. You're left with just an s. Just like if it was a variable in algebra class. do not stress about this if you're not in algebra. I'm just explaining for both people. If you're in algebra, if you're not in algebra, you both are able to do this. Okay, so I'll let you do the next one on your own. And we'll do our last example for distance. Same deal here. You could draw your triangle. And we're solving for distance. That means distance is equal to S times T. And that's how we rearranged our original formula. All right, so I'm going to do the same thing here. Speed equals distance equals and time equals. And I'm going to read my problem. How far can you get away from your little brother with the squirt gun filled with paint if you can travel at 3 meters per second and you have 15 seconds before he sees you? Okay, that's a weird question, but we'll do it anyways. I'm going to underline my numbers. So 3 meters per second, 15 seconds. And I'm going to label my variables. Do I know the speed? Yes, right? Yeah. So my speed is 3 meters per second. Do I know the distance?
No.
No. So I can put an X there. Do I know the time?
Yes.
Yes. So I'll put 15 seconds. So now I'm going to plug in these numbers into my formula, which is distance equals speed times time. And what's 3 times 15?
45.
45. And remember, you are allowed to use a calculator. So please use a calculator. And because I'm searching for distance, my units need to be in meters. Again, you can see that I have M over S. So this is the same as doing like 1S times S, like that. And then they cancel each other out. So then you're just left with meters. If you're curious, don't stress too much about that. But if you're curious why the S goes away, it's because they cancel out like that. Also notice how I always write my units with me. If you wrote just 3 times 15, you're not being specific enough. Because we're in science, you need to be very specific. Because the number 3 could be anything. It could be 3 bananas times 15 oranges. And that wouldn't make any sense. So because we're in science, you need to be very specific. 3 what? 3 meters per second. 15 what? 15 seconds. Gives me 45 meters. Okay? So now you have 1, 2, 3, 4 problems to do on your own. So you're going to finish page 26 during your asynchronous time. If you want to stay, I am more than happy to do those 4 problems with you. If you are confident on doing it on your own, you can leave now and finish that. And then come back if you have questions. And I will post the study guide tomorrow, or not study guide, the answer key tomorrow, so you can check your work. All right, sounds good. I will see you guys tomorrow.